So, in the last class we have read the structures, mainly the pointer to the structures we have read. Now, today we will read another very important programming skills or programming requirement, that the dynamic memory allocation. Okay. So, first we see that what do we mean by dynamic memory allocation. Now, already we have read the variables or the arrays, how we declare in a program, in a C program, or how we use in a C program, that part we have learned. Now, we know that whenever we start programming or we start writing a program, the first thing we do, that we reserve some memories, or in other sense I can tell that we declare the variables that we want to use in a program. So, first thing is the declaration, that means int ABC or float x, that means what are the variables we will be using. So, this declaration means that we are actually reserving memory space for those variables that we will be using in the program. And this the different data type int, float, char, that will immediately tells that how many bytes will be required. So, if I have 4 integer type of variables, we know that 4 into 4, that means 16 bytes will be needed for this allocation, for this storing these 4 integer variables. Now, the problem is that say for array, if it is a integer array and say the array size is 10. So, if it is integer, that means one integer variable requires 4 bytes. So, for array of size 10 means the tail elements are there in the array. So, 4 into 10, 40 bytes will be required for using this array. That means, whenever we declare this array of size 10, immediately these 40 bytes will be reserved. Now, in the program, if it happens that during execution that it requires some more memory, say some the program is written in such a way that some extra another extra elements or 2 elements I require. But since I have stored or I have declared the array for having size 10, so only 40 bytes are kept. So, now if I want to access or I want to keep some another element beyond these 10 elements of the array, then it will create a problem and it will give error. That means, this beforehand or when during the declaration, the storage that we define or we declare the variables, accordingly the memory is stored. So, during execution of the program, if we require some more memory, then it will give a error. Now, the solution is the dynamic memory. Solution is the dynamic memory allocation. So, in that type of program where we cannot predict the amount of storage required beforehand, or in that type of program where number of data items keeps changing during the program. So, it will be creating a problem and it will give a error. So, this type of situations, if it would be the case for this type of situations, if we have provision that during the execution that if more spaces are required, more memory space is required, and that will be generated if required. So, on demand basis, then the problem will be solved. So, dynamic memory management or this dynamic memory allocation gives us that provision. That means, that dynamically it will create storage or create memory space for that particular program. Okay. So, this is the basic concepts. Now, C language requires the number of elements in an array to be specified at compile time, because already in the declaration of an array we have given that how many elements are there. So, this often leads to wastage or memory space or program failure, because there will be the two cases. One is that if I need only 10 elements or 20 elements to be used in the program, but since I know that there will be problem. So, normally what we do in general we declare a array of say size 100 or even 200. That means, always the size of the array is larger than the actual elements are in use in the program. So, this what will happen? So, that means, in my program if it happens that I use only 10 elements, that means, only 10 or 20 elements is required, but we have declared the array the 100 with 100 elements, then the remaining 80 elements, that means, the space I have reserved for the remaining 80 elements, that will be a wastage. And in the other situation that if I save or I declare the array in such a way that I have actually reserved space is much smaller than what actually I require, or earlier what already I mentioned that during the execution of the program that it requires some more memory. But since initially based on the declaration of the array that a fixed storage in the fixed memory is allocated. So, it will give a error or that failure, program failure. So, that is written that often leads to wastage or memory space or program failure. Now, some compilers is very few that where they allow specifying a variable size of array, but not all. Normally, that compiler we use there this provision is not there. Now, dynamic memory allocation that what it does that memory space required can be specified at the time of execution only. That means, if requires that dynamically it will create space or it will reserve space for that. C supports allocating and freeing memory dynamically using library routines. So, this dynamic memory management or dynamic memory allocation is provided by C language. That means, again just if we summarize that memory space, if extra memory space is required, then it will be created during the execution of the program only. And how to do that thing? That actually it will be reading that thing is called the how to allocate the dynamic memory or dynamic memory allocation. So, first we see that how actually memory is allocated when we are using some C program, the process of C. See, already now we have written a number of programs in our lab class, and we know the or we have the concepts of global variables, we have the concepts of local variables, and the instructions means that whenever the C instructions, which is nothing but our the program, because it is a set of instructions. So, now these global variables and instructions, these are actually permanent storage, because whenever we are writing a program or we are executing a program, So, already that program or all the instruction sets of that program that actually is stored in the memory. So, this is actually these instructions. Now, what about the global variables? Because global variables, if you remember that global variables, once it is declared in the program, then that can be accessed from any of the functions, because C program is nothing but a set of functions, is a combination of functions. So, global variables again occupies the permanent storage area. So, these global variables and instructions occupy the permanent storage area. Then the local variables. So, actually local variables can vary, and normally we call this is it is in a data structure called stack. We will be reading the data structure stack later. So, local variables are stored there. Now, in between these permanent storage space and the storage space reserved for the local variables, there is some free memory, and this is called the heap. So, this is a free memory, that means this memory if requires extra space, so this memory will be used. So, this is the concept of my memory allocation. So, whatever I mentioned, the program instructions and the global variables are stored in permanent storage. This is the permanent storage. Then the local variables are stored in another area called the stack, and memory space between these two areas is available for dynamic allocation during execution of the program. Now, the free region is called the heap, and the size of the heaps keep changing, because it is the dynamic in nature. That means, if I need more space is reserved or dynamically reserved, allocated, and whenever the execution is complete or the usage of this memory allocated is complete, then the space will be free for other purposes. So, actually dynamically the space will be allocated and freed. So, in the heap area, this will be this dynamic memory allocation will be occurring in this free memory area, that is called the heap area. Now, we read the what are the C functions, library functions available for this provision of dynamic memory allocation. So, first thing is that the malloc. So, malloc allocates, so this number of bytes and returns a pointer to the first byte of the allocated space. So, memory allocation malloc. So, it allocates because mainly we are using for this thing for allocating number of bytes, and the memory space allocated, that one pointer. So, we have to know that which space it is allocated, that means one pointer you will be returned, and that pointer, it is the pointer points to the first byte of the allocated memory space. So, malloc will do this thing. So, malloc will in summary, malloc will allocate some space or reserve some space in bytes, and then it will return a pointer which points to the first byte of the allocated memory. Now, it is calloc. So, allocate space for an array of elements. See array allocation. So, allocated space for an array of elements initializes them to 0 and then returns a pointer to the memory. So, normally calloc is appropriate or suited for memory allocation of array. Now, what is the difference? See, one extra work it is being done, that it is allocated Alloc allocate space. In addition, it initializes all the array elements to 0 and then returns a pointer to the memory. So, this allocating space and returning pointer to the memory, that is the same, only thing is that one extra thing Alloc is doing, that Alloc is initializing the all array elements to 0. So, these are mainly the for dynamic memory allocation malloc and calloc are used. Now, once the memory space is allocated, that it is the work is over, then this memory is allocated in the free space, that means the heap, that in the heap, and then once it is over, then the it frees previously allocated space, so that the next program can use this thing. So, this free option, this free library function is available in C. Now, another function, library function is realloc. So, this modifies the size of previously allocated space. That means, if it happens that it in a program dynamically some memory is allocated, but still that again it is required to modify that memory space. That means, it wants to increase or decrease that allocated memory. Then realloc, this normally this function is available to modify the allocated space. So, malloc, calloc, free and realloc. Now, we read that what will be the syntax of each of the function. Now, already malloc allocates a block of memory, bytes, a number of bytes we call the block, and that malloc does that thing. So, block of memory can be allocated using function malloc. It reserves a block of memory of specified size, returning a pointer of type void. Since we know the different data type, say if it is integer, it takes a different number of bytes, whereas the float type or character type, that will take a different number of bytes for storing some variables. So, that is why that as if it is general, that first it allocates some memory and the pointer it returns, that it is of void size. If we remember that for our normal pointer type, that pointer, that type of pointer is has the same type as that of the variable it is pointing to, or say the array it is pointing to. So, the data type of the array elements and the data type of the pointer must be the same if that pointer points to that particular array elements. So, in as if it is void means it is no data type is given, and now we can typecast this pointer, return pointer, whatever we require, that means depending on the array or depending on the variables that we want to store there. So, the return pointer can be typecasted to any pointer type. So, what is the general thing? That means malloc is a function that dynamically allocates some memory and it returns a pointer, and the pointer is a void type. And then second step, that this we can typecast this pointer. What is the return pointer? Since it is a void, it can be typecasted depending on the type of the variables or the data elements that we will be keeping on that memory or that memory is allocated to. So, general format is, say PTR is a pointer. So, PTR we are doing the typecast. So, type star. So, this is actually my typecasting PTR type star malloc byte size. So, malloc is a function and it is that byte size, that means how many number of bytes it is being allocated. So, malloc byte size, then the pointer is returned of type, here the pointer returned is of type void. So, this is a typecasting. So, that type star. So, we should give the type of the or data type of the memory element for which the extra memory is allocated. So, then this is the that PTR will be getting this particular data type that we give. So, the general format is PTR type star malloc byte size. So, there are two, malloc has done two functions, one is allocating memory, returning pointer of type void, and we need the typecasting of that particular pointer, and we give that PTR, we are returning that final PTR. So, this is one example of malloc, how to use the malloc. So, first int star p we define, that means p is a pointer of type integer. Now, using malloc, that example can be, since it is of type integer, p is of integer type. So, p equal to, so typecasting required must be of integer type. So, int star and then malloc. Now, number of bytes is 100 into size of int. So, size of int is, we know that 4 bytes. So, that means 100 into 4 bytes, it is 400 bytes. So, malloc allocates 400 bytes and the pointer it returns void type, that is typecasted into int type. Since my p, the earlier defined pointer p is of integer type, that is why it is int star. So, now this p I am assigning to this p pointer p. So, this pointer is assigned to that pointer p. So, and already we have, last class we have read that size of int, it will give the how many bytes required for int and how many elements or how many variables I want, how many integer variables. This can be 100 integer variables, or this can be 100 one array of size 100, that we can also do. So, in memory space equivalent to 100 times the size of an int bytes. So, if it is size of an int is 4 bytes, it is 400, as already I mentioned. The address of the first byte of the allocated memory is assigned to the pointer p of type int, because malloc has two functions, one is allocates memory and returns a pointer. So, returns a pointer, that means the pointer points to the first byte of the memory. So, if this is the allocated space 400 bytes for this particular example, and then p points to the first byte of these 400 bytes. So, this is the function of the malloc, that this example we can use it like this. So, now we see other type of pointer other than integer. Say I define one CPTR. CPTR, this is a pointer name, pointer variable, and type is char. So, this is a character type. So, char star CPTR, that means CPTR is a pointer of type character. So, now if I use then CPTR equal to char star, because data typecasting should be the same. So, this is the data type of the CPTR as already defined. So, char star, then malloc 20, that means 20 bytes. So, this is a fixed, that also we can do. See earlier example that we have given the, this is also 100 into size of int, 100 into size of int, and we are calculating the how many bytes. Here 100 also can change, but size of int is fixed for a fixed compiler. So, here instead of all those I can give some fixed value, say 20 bytes I want to keep, I want to allocate 20 bytes, and then the pointer it returns, we are typecasting because the pointer it returns is the void. Now, it is typecasted to character type, since my CPTR pointer is already declared as the character type. So, it is written that allocates 20 bytes of space for the pointer CPTR of type char. Now, struct stud star SPTR. So, last class we read the structure, and we have also learned that how the size of a structure is determined. Remember, the size of structure is not only the sum of the sizes or the sum of the bytes required for each variable, but it was the ordering is also ordering of declaration of memory members, variable members are also important, and some padding is required if the one variable with smaller bytes are declared followed by a variable which needs a larger bytes, then some padding is required, that we have learned. So, the size of structure is slightly different, or rather I can tell that it is computed in a different way. So, when we want to allocate some memory space or dynamic memory allocation for structure, then our syntax or our concept is same, because once we know that how the size of structure is computed, then the same syntax we can use. See that SPTR is a pointer of type student, where student is a structure. So, SPTR equal to struct stud star. Struct stud star, this is my data type, that it is a structure, and what type of structure it is? This is actually student type of structure. That means, student already it is we have defined a structure where these some memory variables in some order are given. Then malloc 10 star size of struct stud, malloc 10 star size of struct stud. So, this already we know that it will give you the size of struct stud, it will give you the number of bytes required for storing the stud structure. Now, I have 10 number of this type of structures. So, 10 into that many number of bytes. So, this is the malloc this, and then typecasting we have to do, because it will reserves this memory or dynamic memory, then it will return a pointer, and then pointer should be typecasted. Since here SPTR is a structure, so struct stud, because the stud type of structure, that means the student type of structure what we last day also we did. So, it will be typecasted like this. So, see the malloc syntax is same, because the malloc, when the malloc allocates space, that only how many this type of structure or how many this type of integer variables, that so it is 10 here, and then it is computing the size of structure. We know that how to compute, but it will give your size of function will also give you directly the number of bytes required for stud type of structure. Then there are 10 such structures. So, total for storing these 10 structures, what are the memory requirement, and then typecast the pointer that has returned to stud type. So, allocate space for structure array of 10 elements, SPTR points to a structure element of type struct. So, syntax is same for the array, or if it is a constant number of bytes, or if it is a structure. Okay. So, summary is that malloc allocate space depending on the variables to be stored or the array or structure to be stored, and then the how many such array or how many such structure I have to store. So, total it will give you the total number of bytes, it will return a pointer of type void, then depending on the data type of the pointer that it is pointing to, the pointer type will be determined, that will be typecast. Now, some points we must know, that malloc always allocates a block of contiguous bytes, means that it is in a memory, this is in a contiguous, that means successive bytes are there. It is not that in memory one block, some memory space is here, it is allocated, or some are some other places, it is not that type of thing. It is continuous memory, that means it is called contiguous, that one block of memory will be actually allocated. The allocation can fail if sufficient contiguous memory space is not available. Suppose that previous example, say this simple example I see, 20 bytes I want to allocate, but say in my memory, say for 10 bytes are available, 20 bytes are not available, say 10 bytes are available. Then this it will be a failure if it does not get 20 bytes together. If in the memory it happens that 10 bytes are available here, 12 bytes are available here, another say 5 bytes are available here. So, together if we add, it can be more than 20 bytes, but in a single, none of the single block gives us the 20 bytes, then actually it will be a failure, because the malloc allocates a contiguous memory. So, only in one block of memory, in one together it will be allocated. If it fails, malloc returns a null, it is called the null pointer. It is a special type of pointer, that means if it does not work or if it does not get, it is a failure, that means it is a null pointer, that means as if it is not pointing to anything. It is called, it is a special type of pointer, it is called null pointer. So, if it does not allocate any memory, the malloc does not get the space, or for some other error, then it will actually return a null pointer. So, we can write programmatically or write a C program that if p equal to int star malloc 100 star size of int equal to null, that means what we are checking. See, this is nothing but our after using malloc, the pointer we are getting. So, malloc 100 star size of int means 400 bytes, it is of integer type. So, typecasting integer. So, p is that type of pointer. So, if we see that pointer is equal to the null pointer, that means it is a failure. It probably this malloc did not get that enough memory of that 400 bytes together, contiguous memory, so that is a null. So, what we will print, that memory cannot be allocated. That means, what we wanted, that 400 bytes to be allocated dynamically, that is not possible. So, memory cannot be allocated and exit. Okay. So, main thing is that it is, we have to check, if it is a success, then it will be not equal to null, but if it is null, that means it does not work and the memory is not allocated. Now, free. So, once we use we have our program is over. So, we can free, so that it will be the space is free to use for other programs. So, that option is available. So, when we no longer need the data stored in a block memory, that means our work is over, we may release the block for future use. So, by using the free function, and it is very simple, that free PTR, that means the pointer earlier the memory, that malloc function has returned. So, that pointer, if we give the free pointer, that means that it is actually it is freeing, making free that all the spaces whose first byte was pointed by the pointer PTR, where PTR is a pointer to a memory block which has been previously created using malloc. So, this function is syntax is very simple, that free PTR, and this PTR must be the same PTR that after malloc function it has returned. We see one very simple example, that how actually malloc is used. So, we define it is it will give the program is for computing average height of the students in a class. Program is it will compute the average height. So, we see that in the main program what we do, we first declare two integer variable, and one pointer name is height, and the data type is the type of the pointer is float. So, float star height. Okay. Now, this is some float sum equal to 0 and average. This is two variable of type float, and it is initial sum is initialized to 0 and AVG the average the variable declared. Now, printf input number of students, because we want to compute the average height of the students in a class. So, we have to know how many students are there. So, we scanf the number of students in. Now, we have to we want that this memory should be allocated dynamically, that means dynamic memory allocation. So, height is a pointer of type float. So, height equal to the typecasting should be float star. Now, malloc, since n is the number of students, so for each students I need size of float, because I need the height, and height is declared that height is declared as the float, and this is size of float. Okay. Size of float. Now, size of float we know that if it is 4 bytes and then number of students, it will be total it will give the total number of bytes required. So, if height equal to null, that means first I am checking that whether the memory is allocated or not, because if this pointer height equal to null pointer, that means memory is not allocated. That means enough memory was not there, or say there may be some other error, but that memory is not allocated. But if not, that means if it is not null, that means memory is allocated, height is pointing to some memory byte of the allocated memory space. So, printf input heights for input heights. So, input heights, and that is the n of heights for n number of students, because n we have given the number of students. Now, number of students that we are giving, we have to read the number of we have to read the heights of every students. So, what we are doing for I equal to 0 I less than n, for each student we are reading the ampersand height I. That means one height, here height, one array is also there, height. So, for I equal to 0 I less than n, I plus plus sum equal to height I. That means, now we are in this loop, we are just adding. Here we have read the height of each student. Here we are doing the sum of, we are computing the sum of all the heights of all students in a loop, n number of students, capital N is the number of students. Then we are doing average, because I have to compute the average height. So, now we know the total heights and I know the total number of students. So, AVG is sum divided by float n. Why it is float n? Because see, sum is also float, here sum is also float and n is declared as integer. So, as if we are that giving this float n. Okay. Now, printf average height equal to AVG and then free height. So, now we are printing that average height equal to AVG and this free height, that means once it is done, that we are this memory we have allocated for the this height, that actually for this pointer height pointer, that actually free PTR. So, free height pointer here. So, this is one very simple example that we know. Then similarly, another earlier we have not used any array. So, this is one array what we can do, or this array of structures, one array of structures. So, remember the type def or the new user defined data type, the type def struct, roll number, department code, which is again one array, and float CGPA stud. So, stud structure we have defined, or stud here actually a new data type, type def we have done. Stud is a structure having 3 member variables, integer, char and float, 3 different type and struct. Now, we write the main program. So, stud class, star class and T. So, class is a pointer, class is a pointer of data type stud, the student. So, already we have defined a student as a new data type. So, that type of pointer. T is also a student data type, but here class is a pointer, T is a structure, simple structure of student data type. Then I define some integer variables what we will be using in the program, that I, j, k, n and float AVG. So, this is float type. So, first thing we read the number of students, as usual that we scan fn. Now we define we allocate memory, dynamic memory. So, my pointer is class, type is stud. So, class equal to stud star, because data type already new data type, like int, float, char, stud is now a new data type. So, stud star typecasting we have done, pointer it, and then malloc n into, because I have number of students n. So, for each students I need roll number, department code, CGPA, that type of, each student is that structure. So, n into size of stud, n into size of stud. So, that means this many number of bytes, n into size of stud, this many number of bytes are required or I want to allocate dynamically. Then the memory, it is returned, it is typecasted to the stud type of new data type that is defined, a structure, and it is returning a pointer, the class of type stud, because it is declared class is a pointer of type stud. Now, for each student we are reading the data of each student, for because n number of students. So, in a loop we are reading, and already we know how to read or how to access the variable member, that if it is the structure name dot the variable name, name of variable member. So, it is ampersand class k dot roll, ampersand roll, then class k dot department code, because it is a array, that is why ampersand is not required, because array itself, the name of the array is actually the address, that means address of the first pointer, that is why ampersand is not given here, and ampersand class k dot CGP, class k dot CGPA. Okay. Now, we compute average CGPA. So, initially average is kept 0 and then we are taking the sum, we are taking the sum of all the CGPAs for each student, n is the number of students for each student. We take the average, that is AVG is here the sum of the CGPAs of all the students and then divided by n. So, it gives the average and then we do the we make the space free once it is over. So, class is a pointer to the starting address of the allocated memory, already we mentioned. We can therefore access the individual elements like we have done class k dot or class I dot, like this type of thing. As an alternative, we can also use pointers and the arrow notation. Remember the last class we have read the pointer to structure, or so there we know that instead of class dot we can use also the arrow, then the class k arrow role. So, instead of dot, that also we can also use. Now, realloc. So, sometimes we need to alter the size. So, more memory is required. So, it is reallocation is required. So, by using the realloc function you can do. So, if the original allocation is done by ptr equal to malloc size, if the pointer is ptr, then the reallocation is ptr equal to realloc ptr new size. See here there are arguments, the two arguments, because already the pointer that it returns for the allocated memory, that pointer we are using, and the new size because we want to reallocate. So, that new size is given. So, it will give you the reallocation. This is the syntax. Now, new memory block may or may not begin at the same place. Please notice this thing, because for malloc it was required that whatever memory size we required, the number of bytes that must be in one place only, contiguous memory. But when we do the realloc, the extra space that can be in a different place, So, realloc may create the new block in an entirely different region and move the contents of the old block into the new block. The old block will be released using free. So, realloc, when we do the previously allocated memory with the data already we have stored something, with all these things it will be shifted to the new space allocated by realloc, it will be. So, the previous space allocated by malloc, that will be free. So, the function guarantees that the old data remains intact, that means, when it is shifted the memory allocated by malloc, then with the previous data that it will be shifted there. If realloc is unable to allocate, it returns null, the original block is left untouched, it is not free or moved. It is same as that of malloc. If realloc does not do, the original malloc will be there. Now, it is a calloc. Calloc is allocate memory and initialize, because only difference was it initializes the array elements to 0. So, it takes two parameters instead of one, it initializes the allocated memory to all 0, only the second point is different. It also returns a pointer of type void. So, ptr is type star, calloc, int int size. Here also see the arguments are two arguments. So, calloc also take that int n and int size, that number of elements. Example is that int star p is int calloc 20 size of int. Okay. That means that n is the number of elements to be allocated and the initialized all the elements as 0. So, this is an integer array. So, 20 elements are there, it will be allocated that size, and in addition it will be initialized to 0. So, we read the dynamic memory allocation, and this is very important because so far the program we have read, at the beginning of the program we declare the variables or the array structure, and we know this by this declaration means immediately the memory spaces are reserved in the memory spaces are reserved, and these spaces reserved we know that for integer, for character, for that means for each data type, or if it, even if it is a user defined data type, that is for structure, that how many bytes will be required, that is fixed. So, accordingly it is immediately during declaration the memory spaces are fixed. Now, if it happens during the execution that some more memory is required, then unless we get some extra space, then it will be it will give error, because it will not be getting any extra memory space. For that dynamic memory allocation we do, for that we use the malloc, calloc, and reallocation is again after malloc again we need extra space for that reallocation, then we can do some reallocation. We read the syntax how we can do this thing, and mainly malloc and calloc both it allocates memory and returns a pointer. In calloc, in addition, that calloc mainly used for array, and for each array element is initialized to 0, and we see that we have seen that how they are used. And another thing, that after using this malloc, calloc or realloc, that means extra space allocation, once the program execution of the program is over, then we use free function for making the space free for future use. So, this is very important, and we will be doing some practical problems in our lab class using dynamic memory allocation. So, next week lab or this week lab actually we will be doing the problems with dynamic memory allocation. Particularly in section 3, we will be giving the problem with dynamic memory allocation. So, students, you must prepare, you read, and if you have any questions, I will be telling that how we will be doing some, we will be arranging some live sessions. So, whatever confusion you have and the questions, that we will be discussing over the live session. Okay. So, here is the end of this class.